So hello everyone. Um okay. So thank you very much for joining today. Um okay. All right. So if you have joined, um just give me hello sir or type something for me to know that you are here. Okay. And then share the link to your friends. We are about to start. So in today's tutorial, we'll be looking at um centroid, and then we'll look at some pulley question, but then I would also look at the truss using um the method of section. Okay. So in today's tutorial, um all right. So all right. I hope everybody can hear me. All right. Okay. Okay. So I'm about to start. Um so yesterday we looked at a question on centroid, okay? But that question was you know a question whereby you would be given a centroid. Sorry, you'll be given an area and you'll be asked to find the centroid of that area. Okay, but this one, it is not let's say like a triangle or a rectangle or any regular area. Okay, so when you are given something like this, how do you solve it, or how can you solve this type of question? So we are going to use what we call the method of integration. All right. Okay. All right. So I'm about to start. Um. So basically, whenever you are given a question like this, actually, it is not basic mechanics. This is actually calculus, because you are going to use calculus. So we call this the method of calculus, or the method of integration. So the method of calculus, or the method of integration. All right. So first of all, um, when you take this figure here, okay, and then you have been asked to find the x and the y coordinate. So what you do is that you take a portion of this section. Okay. So let's say you can choose. So you can either choose um a region along the x, or you can choose a region along the y. So for this question, I have decided to choose the region along the x. Now pay attention. We call this our elemental area. So elemental area. Now in this elemental area will be called dA. So simply put, it is like small area. That's how we actually look at it. So consider the whole of this as a complete area, okay? And then you are taking just a small portion of that area, okay? So it's like you have an area and you are taking a small portion to do the analysis on that area. All right. So now that you have taken the elemental strip, this is what you are going to do. You are going to say that this area is similar to a rectangle. So this area is similar to a rectangle. And then this rectangle has a height. And then, so think about this area here as a certain rectangle which you have chosen. So we are thinking about the elemental area as this, okay? So you have a rectangle, and then it has been shaded like this, okay? So think about this area as a rectangle. Now let's say that this function is what? Y equals, so we have y equals k2 square root of x, okay? And then we have y equals k1 x cubed, okay? So what this means is that I can treat this function as, let's say I have a curve, and then this point is, let's say, x1 y1, and then another curve. So I have another point here, x2 y2, okay? So x1 y1 is like any arbitrary point on the first curve, and then x2 y2 is also any arbitrary point on the second curve. So now the enclosure of the curve, or the the enclosure of this curve and then this curve will yield an area, and then we want to take a portion of that area and do the integration. All right, so what will be the length? Now, to be able to calculate the length, this is what we have to do. First of all, we have to understand that the distance from the origin to this point is x1. That is the distance. And then all the way from here till we get to the end point, the distance is x2. Okay. So now the idea is that if we have x1 and x2, then what will be the distance from here to here? Anyone to help us? Can anyone help us? We know that the distance from here all to, let's say, point 1, and then let's call this let's say some point 2. So this is x1, and all of this the distance all the way till we get to point 2 is x2. So what will be the distance between the 2 points? It's going to be x2 minus x1. So if we take the centroid and bring it down here, we can say that the entire distance here is x2 minus x1, and that gives us the distance, the length of the rectangle. But what will be the height? So what will be the height of the rectangle? So it is simple. The whole of this axis is y, okay? The whole of this axis is the y axis. So if I take a small portion of the y, in other words, if I take a small area in the y, then I can call that area dy. Okay, I can call that area dy. Sorry, I can call that height. Sorry, the whole of this height is y, and then I have taken a small portion along the y, and that is more or less like the thickness. Okay, the thickness of the elemental area. So that is what we are calling what dy. So what will be the area of this rectangle? So the area of the rectangle, we call it dA, and it will be given by the length, which is x2 minus x1, and then you multiply by the height, which is dy. So we can clearly say that the elemental area is having this area x2 minus x1 dy. I hope it is clear up to this point. Okay, so now that we have been able to establish this, let's go ahead and substitute the values inside. Right now, what do we know? So we know that S2 so now we know that S2 is coming from this curve, and then x1 is coming from this curve. So let's do this. This is what we can say. So we can say that y1 is equal to k2 square root of x1, and then we can also say that y2 is equal to k1 x cube, so x2 cube. Okay, all right. Now at this juncture, we can substitute these values direct, so that we can see that our dA, which is our elemental area, is going to be what? S2 minus x1 dy, which can also be written as what? The second x, which is, so from here, what is x2? If I solve for x2 from here, I know that y2 is k1 x2 cube. Therefore, solving for x2, I can say that x2 will be y2 divided by k1, and then this is cubed. So it means that if I want to find s2, then I will say that y2 over k1 minus y2 over k1 to the power 1/3, and then if I want to get x1, then I will go back, and then I know that y1 is k2 square root of x1. So if I want to get x1, I will rather square both sides. So it's equal to k2. So if I square, okay, let me do it this way. So square root of x1 will be equal to y1 over k2. Therefore, x1, if I square both sides, s1 is going to be y1 over k2 all squared. Okay, all right. So now that I have x2 and then x1, I can go back and put it into the equation. Okay, so now I can say that my x2 is going to be y2 k1 1/3 minus y1 k2 squared, and then everything into this, and then dy. All right. Okay. But then actually, they are all in terms of y, not y1 and y2. I just did it so that you can understand where we are coming from. So at this point, you can just go straight away and say that dA is actually going to be y. So y divided by k 1 1/3 minus so minus, okay, y divided by k2 squared, and then dy. Okay, so now that we have this, what can we do? So okay, so we can say that our dA is going to be okay, so we will just have to integrate it, right? We will just have to integrate it. But then what do we know? Okay, before we do the integration, I want us to look at something here. So we know that okay, this is the expression for dA. First of all, I don't want to confuse you. So first of all, this is the expression for dA. That is to say the elemental area. Right now, I want us to look at the first moment of area. So the first moment of area, Qx, or let me do it this way, dQx. So that is to say the elemental, yes, they are of different curves. They are of different curves. However, the function is all about y. So the function is all about y. But then y1, x1 was about the point. Okay. All right. Please, this video is being recorded. So after the video, you can still go back and watch. Okay. The main idea here is that we are trying to relate some points on curve 1 and curve 2. And then we are putting these 2 points together so that you can get one expression for the elemental area. Okay. All right. So now the first moment of area about the x-axis is actually y dA, and then the first moment of area about the y-axis is x dA. Okay. All right. So if we want to find Qy, we will have to integrate x dA. And then if we want Qx, we would have to integrate y dA. All right. Okay. So now this is what we have to do. We have dA. So to get how do I put it? To get any of them, whether Qy or Qx, we just have to multiply For instance, if we want QX, what we have to do is we will just integrate. Okay, we will just integrate. So we can integrate, but what are we doing the integration? What is the limit? So don't forget that from the origin to the x-axis is a, and then to the y-axis is a, which means the limit of our integration will be from 0 to a. Okay, and then we will multiply y by dy, which means that we will multiply dA, which means that we will multiply everything here by what? Y. So let's simplify this. So Qx is going to be integration from 0 to a. So I'm going to multiply through by y. So this one is going to be y. So if you have y multiplying y to the power 1/3, then they will add. Okay. And then so I have k minus 1/3, or okay, let me just put it just as it is, 1 over k1 cubed, and then okay, let me do it this way, 1 over k1 cubed I want to take this one out. I want to take this one out, but I know that y will be 1/3. So basically this one will be 1 over k1, and then the 1/3 will come and take it. Okay, but then this one, the y here, will multiply the y outside, so that we get y. So what is 1 plus 1 out of 3? So 1 plus 1 out of 3 is the same as 3 out of 3 plus 1 out of 3. So here becomes 4 out of 3. Okay. Minus, so 1 over k2 squared and then and then I also have so this one is y squared. If it multiply another y, we'll get y cubed. Okay, so we are done with the multiplication. Now we have to integrate, but because the k1 and the k2 are constants, they do not take part in the integration. Okay, so we can just go ahead and see that Qx is going to be, okay, let's do the integration. So 1 over k1 cubed minus, so the whole of this is actually 4 over 3 plus, so we are doing integration, we add 1, then we divide by the new power. So 4 over 3 plus 1 is the same as 4 over 3 plus 3 over 3, which is what? 7 over 3. So all what we are trying to do is that we are trying to integrate. So we are trying to integrate this one. Let me write it here. We are trying to integrate y to the power 4 over 3. And then for integration, all what you have to do is what? You just have to add 1, divide by what? The new power. Oh, sorry. So it's going to be 4 out of 3 plus 1 divided by 7 out of 3. All right. And then from here, all right. So this is just the first part. So minus, this one is a constant, so it doesn't have the integration. We can bring it outside the integration sign. And then this one here is y cubed. Please, the constant is not subtracting, it's actually multiplying. So y cubed plus 1 divided by 4. And then we are doing the integration from 0 to a, which means that wherever you see y, you put 0 there. Okay, so qx will now become what? Qx will now become okay, so qx will now become 1 over k1 cubed multiplied by a, and then this part will be 7 out of 3 divided by 3 multiplied by 7. Oh, sorry. It is 7 out of 3. So it's going to be 3. Okay. It's going to be 3 out of 7. A. 7 out of 3. Minus 1 over k2 squared multiplied by a 4 divided by 4. So actually this is what you get. But then you see, this is all what we are doing here is not basic mechanics. Whatever we are doing here is calculus. So this question is not really basic mechanics. The whole idea from the basic mechanics is that we just want to find the centroid using calculus. All right. So this is going to be the qx. Now from here, if you want to find the x bar will be don't forget that qx is actually y bar times area, and then qy is x bar times area. So if we want to find, so if we have qx and we know the area, we can find y bar. And then if we know qy and then we have the area, we can find x bar. So right now I want us to use the same principle and solve for qy. So we know that dqy will be integral of what? X dA, right? So dqy will be the integral of x dA. Right now we have done y dA, so now we need to do x dA. All right. Please, any question up to this point? Any question up to this point, please? Okay. So let's proceed. I want us to take notice of this. When we are dealing with the S bar, the question is, we need to come back and look at this carefully. So, who can help us? Who can help us? What will be the centroid? So, this is what we want to do. We want to try and see if we can find our way to the center of this figure. So this area here, can we come all the way to the center? Let's say the center is here. Now don't forget that still this is x1 and this is x2, but we want to find the center, which will divide this area into two along the x. So that is what we are after. Now, interestingly, the x bar, there is a formula to calculate that. There's a formula to calculate that. But can anyone help us? From here to here is x1, and then from here all the way up to here is x2. So this distance, so let's think about it this way. From here to here is x1 that we are talking about. But we know that this portion here, which is left here, is x1 minus x2. So it means that the centroid will be somewhere x1 minus x2, which is this portion here, and then we divide by 2. Okay. So basically what we want to do is that we want to come up with an expression for the centroid about the x direction. Okay, so it's going to be x1, which we know, plus something. Sorry, this is supposed to be x2 minus x1 divided by 2. Now if we do the algebra, you end up getting x1 minus x1 over 2 plus x2 over 2. Okay, if you do the algebra, you end up with this. Now interestingly, you can see that x1 minus half x1 is going to what? x1 minus half x1 is going to be x1 over 2. So it means that you are going to get x1 over 2 plus x2 over 2, which means that the centroid is x1 plus x2 divided by 2. I hope the concept is clear. So what we are trying to say is that the centroid about the x is going to be, so it's going to be integral of what? x1 plus x2 all divided by 2. And then we multiply by dA. Okay? But don't forget that already we know dA, right? Already we know dA. So what is dA? So so what can we say then? I want us to pay attention here. I want us to pay attention here. dA was what? Watch this, everyone. Watch this. dA was x2 minus x1 dy. So if you bring this here, you are going to get something like this. Integral of x1 plus x2 divided by 2. And then you multiply by dA, which is what? Okay, let me bring the half outside. So it's going to be half the integral of x1 plus x2 multiplied by dA. But dA is what? x2 minus x1 dy. Right? So interestingly, what can we say? So we can go ahead and say that from here, we can clearly see that we can actually go back and then solve this one as dqy to be what? 1/2 the integral of what? Now this one becomes difference of two squares. If I have x squared minus x1 squared, it is the same as x1 plus x2 squared minus x1 squared is the same as x2 plus x1 multiplied by x2 minus x1. Okay, so in other words, this one becomes a difference of two squares. That's all. Okay. Any question up to this point, please? Any question up to this point, please? Okay. So we just have to go back. So we have our we have y1, and then so basically this is what we have here. 1, 2. Okay. All right. Okay. Thank you very much, Hakot. Thank you very much, my good friend. So basically we just have to find the relationship between x1 and y1 here. Let me just copy everything and send it there. Okay, so with this that we have here, we can clearly see that make x2 the subject, x2 squared. Okay, so from here, y equals k2 square root of x, and then y equals k1 x squared cubed, meaning that if I square y, or okay, it means that y, so it means that y over k2 squared will be what? X. But we want x squared. So it means that x squared will be actually y over k2 to the power 4. Because we are interested in x squared. Alright? Alright. Now, we know that y over k1 is what? X cubed. But we want x squared. So we can say that y over k1 is the same as x squared multiplied by x. So meaning that y divided by k1 multiplied by x will give us x squared. Okay. And then we just have to, so I want us to come back here. We can say that dqy will now be what? 1/2 the integral of, so x2 squared minus x1 squared dy, which is the same as 1/2 integral of so the x2 squared is what we did, and then we got what? So this one is from the x2 and this is from the x1. So then it's going to be y divided by k1 multiplied by x, and then minus y to the power 4 divided by k2 okay, y divided by k2 to the power 4, and then whatever we have here, or in bracket. So up to this point, one thing that I want you to understand is that there is nothing basic mechanics here. It is only calculus that we are using. So at this point, if you are not really good in your calculus, you will struggle with this, which does not have to do with basic mechanics. So at this point, I want to urge you all to revisit your integration to be able to understand what we are doing. Okay. So basically, if we want to do the integration, then it means that with this, we can say that our ky will be what? 1/2, and then we are going to integrate. So since we are integrating with respect to y, we'll treat the x as a constant. So it will be um okay. So all right. So it's just going to be integrating y, which is what? Y squared divided by 2. And then I will multiply this with what? So let me write it well. It's going to be y squared divided by 2k1x. All right. And then minus the integral of this one. So it's going to be y to the power 5 divided by 5 k2 to the power 4. And then so the integration is also running from 0 to a. All right. So wherever you see y, you put a there. So we are going to get 1/2 divided by a squared 2k1 multiplied by x minus a to the power 5 5k2 to the power 4. So you get something like this. Any question up to this point, please? Any question up to this point? Please, is there any question? Okay. I'm still waiting if there is any question. All right. So, interestingly, we need to find the area. And the area is actually integral of dA. So I want to leave this to you to go and continue. Now this is dA. This is dA, which is the area. Let me copy it here. So this is dA. I leave this to you as integration. Integrate this with respect to y. Integrate this area. It's very simple. You can do it. Okay. I mean, let me just do it for you. So the area will be what? Integral of the whole of this. And what is it? It's just going to be y 4 out of 3, which is like integrating. Oh, sorry. Yeah, y 4 out of 3 divided by 4 out of 3 multiplied by k1 to the power 1/3 minus y cubed divided by 3 k2 squared. So this is actually the integration, but the limit of the integration is from 0 to a. So wherever you see y, you put 0 a there, sorry. So it's going to be a 4 cube, but the 3 will come. So 3 over 4 a 4 out of 3 cube divided by k1 1/3 minus a cubed divided by 3k2 squared. So in fact, this is the area. If you want to get the x bar will be qx divided by the area. Qy divided by the area, and then the y bar will be qx divided by the area. So you have to take your time and then put ky here. So this is the ky. So this one, you divide ky by the area, then you get the expression for x bar, and then you divide qx, which is this one, by the area, and then you get the y bar. Some of the terms will cancel out, but this one is algebra, so I want to leave that one to you so that you spend some time and simplify this. Okay, so please, is there any other question, or is there any question at this point? Do you have some questions? Okay. So what I want us to do is that I have solved about 20 questions on centroid. Please, I have solved about 20 questions on centroid. And what I am dealing with you with this question, I have solved about 5 of them. So try and get the playlist and watch the videos, because I have solved about 20 questions on centroid. And then if you have any challenge, you can reach out to me. So at this point, I want us to move to another topic. So what topic do you want me to move to? What topic do you want me to move to? I would like to do the trusses, but this time using the method of section. And then, or some people are saying pulley. Someone is also saying friction. So please, which topic? Okay, someone said trusses. Any other? Okay, so I want us to look at the. Someone said pulley, someone said trusses. Interesting. So, okay. So what I want to do is that I want us to quickly. Someone said, why was the DQ introduced? So basically the DQ there is actually the elemental area, the elemental first moment. So for instance, if you want to find KOX, which is the first moment of area, then you integrate the small, because don't forget that we are dealing with integration. So that is why we have DA. Okay. So the DA is like you have a small area and then you are integrating that small area. Okay. So DQ is like you have a small first moment of area and then you are integrating the first moment of area. Okay. All right. So without wasting much time, I want us to look at the trusses, which is like using the method of section. And then I'll quickly look at the pulley. But the pulley is, I mean, it's a lot. But I'll try out one question which I solved with some students some other time. Um, and I think you understand the concept actually. Okay, so I want to look at the trusses with you using the method of section. Please, the simple machine, you just have to memorize the formulas for an inclined plane, for the screw, and all of this. I mean, you have to just memorize the formulas. That's all. You'll be fine. Okay. So, okay, I want us to. Okay. So, there is a certain question here. I want us to solve it. All right. So, now let's look at this question here. All right. So, we have a question here. And then the question is saying that we should determine the forces in members EF and then GI of the truss. Okay. So so this is the question, and then we've been asked to find the force in members EF and then JI. Okay, so we are going to use what we call the method of section. Method of section. Why are we calling it the method of section? So it simply means that whenever you have to use the method of section, you will cut some portion. Okay, you will cut some portion. But before we do the cutting, I want us to do something right now. I want us to first of all find the reactions at the support. Okay, first of all, what is the reaction at the support? Right now, we have a pin joint at B. So this one is a pin or a hinge. And then whenever you see some small ball or something like that, it's actually a roller. Okay, so there is a roller at J. So I'm not going to redraw the diagram again. I'm not going to redraw the truss again. But we know that whenever we have a hinge joint, it has two reactions. Okay, so there will be a reaction along the X. I'm sorry. So there will be a reaction along the X, and then so let's call this BX, and then there will be a reaction downwards or upwards, I mean in the Y direction, sorry. So BY, and then at the ruler, a ruler has only one reaction, so let's call that reaction as JY. So please listen to this carefully. Please listen to this carefully. Whenever you have a truss question, whether it is method of section or method of joint, it doesn't matter. The first thing to do will always find what? The first thing to always do is what? Find the what? Support reaction. That is the first thing to do. Always. In any question which is truss, find the support reaction first. Please. Find the support reaction first, please. Okay. And how can you find the support reaction? So we are going to use equilibrium of a rigid body. Equilibrium of a rigid body. Okay. Now, if a rigid body is in equilibrium, that body must obey two conditions. Okay. Whenever a body is in equilibrium, number one, summation of forces in every direction. So along the X is 0, along the Y is 0, along the Z is also 0. But then because you know this whole member is a planar truss, we don't consider the Z. So we say that summation of force along the X is 0, and then summation of force along the Y is 0. And then the second condition is that summation of moment about any plane is always going to be 0. So you can take moment about point B, about point J, any point at all. Okay? All right. You can take my contact from the class rep. You can take my contact from the class rep, please. So if you want to reach out to me, you can take my contact from the class rep. Thank you. So summation of moment about, let's say, point B should be what? 0. All right. Now I want us to do this together. We are going to sum all the forces along the x direction. So every force to my right, or in this direction, is positive to be equal to 0. So let's go to the diagram. How many forces do you see which is in the x direction? So we have bx, and then we have 16 kip, which is actually kilo-pound force. Okay, so we can say that minus bx plus 15, is it 16? Yeah, 16. So 16 should be 0. In other words, bx is 16 kip. Okay, I will leave it there. All right, so bx is 16 kips. Now let's look at the forces in the y direction. Every force going up is positive, should be 0. So you come back to the diagram. How many forces are in the y direction? So by is coming down, so we will negate it. So minus by, and then 28 is coming down, and then another 28 is also coming down. So we'll say that minus 28 times 2, and then there is jy going up, so plus jy to be 0. So we can say that jy minus by is equal to 2 times 28. So pick your calculators. What is 2 times 28? That is 56. So let's call this equation 1, and then let's call this equation 2. But I have 2 variables in one unknown. Okay, I have 2 variables in one unknown. So it means I need an extra equation to be able to solve this. Okay, I need an extra equation to be able to solve this. Now, since I need an extra equation to be able to solve this, then I need to use what? Moment. Okay, if you need an extra equation, it will come from moment. So now we will sum moment about point B, and then clockwise is positive to be what? 0. All right, so now let's sum moment about point B. We will take all the forces and sum moment about point B. Okay, so summing moment about point B, what can we say? 28, and the moment arm is what? 8. Now watch this. This 28 kips is going to cause a movement in the clockwise direction about point B. So 28 multiplied by 8, and then the same 28 will cause clockwise, but it will be the moment arm will be 8 plus 8 plus 8, and that distance is going to be So 8 times 3, which is what? 24. So plus 28 times 24. And then I'll do the last one. Oh, sorry, I'll do it for 16 KIP. But look at this carefully. The 16 KIP is at point K. And if you look at it carefully, you see that it is far away from point B. But how can I take the moment? Yes, it is possible. You have to use what we call the principle of transmissibility. So the principle of transmissibility. Now, this principle is saying that if I know the line of action of a force, which is always a straight line, then I can place the force on any at any point on the line, and then it will produce the same effect. So it means that I can bring the 16 KIP to this point. Okay, I can bring this force to this point. Okay, so I can even bring the 16 KIP here. And then the distance from A to B is 10, which means that the moment arm for the 16 KIP is 10. So it's going to be 16 times 10. So plus 16 times 10. All right. Now, when you get to this point, then you look at the JY. Okay, look at the JY. Then you realize that for JY, it's going to be minus 10. Oh, sorry. JY is going to be counterclockwise. But then the moment arm is what? 8 plus 8 plus 8 plus 8. Which is what? That is 8 times 4. Which is what? 32. So 8 times 4 is 32. Okay. So it's going to be 32 JY. That's it. So that is it for you. Now this should be equal to 0. We'll be able to calculate JY, which means that from here 32 JY will be equal to, let's put everything together. So 28 times 8 plus 28 times 24 plus 16 times 10. That's going to be 1056. And then JY will be divided by 32. So JY is 33 KIPS. So that is JY. Then we come back to equation 2. So if JY is 33, then it means that JY minus BY is 56. Alright? So then BY will be what? JY minus 56. Which is what? 33 minus 56. And what do we get? Okay, the 16 kilonewtons. Yeah, it's along the X direction, please. It's along the X. Okay, I don't know the question you are trying to ask. So you get BY to be minus 23 KIPS. Now, the fact that we got negative means that the direction that we choose is the opposite. So BY is supposed to go up. Now we know, so we can put it there. 23 KIPS, and then bx is 16. And then jy is 33. Okay, so now that we have now that we have what we are interested in, now let's um let's start with the method of section. What does it mean? So now we know by is 23 kips. So to do the method of joint, number one, cut through. So cut through exactly 3 members. Please, exactly 3 members. If you cut less than 3 members, it will not be possible. And if you cut more than 3 members, it will not be possible. So all the time you have to cut through exactly 3 members. Okay, exactly 3 members. So for instance, if you have been asked to find, for instance, the force in member EF, then you ask yourself, where is member EF? So member EF is this one. That is member EF. Okay. So now that you have member EF, then you ask yourself, how can you cut 3 members such that it will pass through member EF? That's the question you want to ask yourself. How can you cut such that it will cut through member EF? Please, the moment is correct. I will advise you to watch a video I have done on moment. If you want to understand moment, please spend some time and watch the videos I have done on moment. This one is just application, so I cannot spend a lot of time on the moment. Thank you. Okay, so now we have two choices. We have two choices. We can either cut such that it will go this way, or we can cut this way. But what do you think? If we cut it this way, we will cut more than 3 members. So we cannot cut it that way. But then we only have to cut it this way, so that at the end of the day, we cut through only or exactly 3 members. So all the time, whenever you are dealing with method of section, make sure that you are cutting exactly 3 members. Exactly 3 members all the time. Whenever you are dealing with method of section, make sure you are cutting through exactly 3 members. Okay, so right now that you have been able to cut through such that it is passing through EF, now you are going to split. So now you are going to split the whole truss into 2. Okay, you are going to split it into 2. Now this is how it is going to look like when you split it into 2. So I'm trying to, okay, let me just copy this here. Okay, so if you watch the diagram carefully, you will see that if you stand here, and then you cut through, it will be left with A, C, E, and some extended portion. And if you come down, you will see B, D, and then some extended portion. And then you see that all of these points here. So this one will not come. Okay, so you have section. That's why we are calling it section. You have cut that portion away. Okay, so you have cut that portion away. So this is what we will get, because we have been able to cut through E, F, and then D, F, and that is exactly what we have done here. This one. So that's exactly what we have done. So you can see that that F portion is missing because we have cut away. Okay, so now this is what the method of section is saying. If the whole truss is in equilibrium, then any portion which I also cut is in equilibrium. Let me say that again. The method of section is saying that whenever you take the entire truss and it is in equilibrium, then each portion that you cut will also be in equilibrium. So in other words, this portion that we have cut is also in equilibrium. But what did we say? We said that if a member or a rigid body is in equilibrium, summation of force is 0, and then summation of moment is also what? 0. So we will apply just like when we are about to find the reaction forces, what we did. So we said equilibrium of a body with a rigid body, right? We said summation of forces is 0, summation of moment is 0. So we'll do the same thing to this one. So we'll do the same thing to the cut portion. So let's do it. Let's do it one more time. We are going to take our time, some forces along the x to be 0. Let's do that. So we have 16 kips here. So it's going to be minus 16, and then FEG is along the x. So it's going to be plus FEG. And then FDF. So plus FDF. So is there any other force along the x? No. So to be 0. In other words, FEG plus FDF should be equal to 16. So call this equation 1. Okay. And then look at the body again. Some forces along the y. Every force positive to be 0. And then what do we have? There is supposed to be a reaction in the y direction, which is 23 kip. It is here. 23 kips. So that one will come going up. It's positive. And then the 28 is coming down. Okay. So we have, so plus 28, sorry, minus 28. And then FEY is coming down. So minus FEF. That one is coming down. Okay. So from this one, we can clearly see that we can solve for FEF straight away, because there is no other force along the y direction. So FEF, or the force in member EF, is going to be 23 minus 28, which is what? Minus 5 ki ps. So that is it. First of all, we have been able to solve for FEF. Now, because it is negative, we can say that this is a compressive force. So because it is negative, you can say that this is a compressive force. Why? Because it is negative. Okay. And then for the, so now don't forget that we have two unknowns with one equation. So we need another extra equation, which will come from what? Moment. So let's solve moment. Let's say clockwise is positive, should be 0. About point. So let's say we are summing moment. Okay. So this is also one thing that you have to take notice of. Whenever you are coming to take moment in a problem which is method of section, you have to take the moment about a point which will give you which will eliminate, let me put it that way. You have to sum moment about a point which will eliminate a force. So think about it this way. You have FEJ and then FDF, but you want to eliminate one of them. So it means you cannot take moment about any point at all, but you can take moment about any of these, so that at the end of the day, if you take moment about those points, then it will eliminate one of them. I hope the concept is clear. Let me go again. Whenever you are solving a method of section question, and then you want to find the force in a member, you want to eliminate one of the forces to get the other one. So you take moment at a point so that you can eliminate a force and get the other force. Okay. So if you look at this carefully, if I look at FEG, I can take moment about E. When I take moment about E, what will happen? Taking moment about E, I will be able to resolve. Okay. I will be able to eliminate one of this, either FEG or FEF. All right. So now let's take moment about E. So taking moment about E, what can we say? So we are going to take moment about E. That is this point here. Okay. So starting with so we can start with any of them. Starting with the 28 kilonewton here. The 28 kilonewton will have a moment which will go counterclockwise, okay, about point E. So, but then all the distance is 8. So clockwise is positive, so you can say that minus 28 multiplied by 8. Then we will come back and look at FDF. FDF, the line of action is along this straight line. So this is FDF. Now the line of action, the perpendicular distance all the way, from point E to meet FDF So that perpendicular distance is what? Is actually 10. So that is the distance, the vertical distance in this direction. That is 10. So it's going to be but then let's look at it. It is going to be counterclockwise about E. So minus. So F, okay. So 10 F D F. And then let's look at the 23 cape. So you see that the line of action of the 23 cape is actually in this direction. So that is the line of action of the 23 cape. So we just need a perpendicular distance to this point E. And that distance is going to be 8 plus 8. Okay? Which is what? 16. But then the moment this time around is going to be what? Clockwise. Because this one will turn it in the clockwise direction. So 23 times what? 16. So that is for the 23 cape. Now let's look at the 16. So considering the 16, the line of action will be passing through like this. So please, if you have forgotten moment, go back and look at moment. Okay. Now, the moment arm or the distance will be from here all the way up to here. And that distance is 10 feet. But then the moment will cause this rotation in this direction, which is clockwise. So, in fact, by the principle of transmissibility, we can bring the 16 cape here. So the actual movement is going to be in this direction, which is what? Clockwise. So it's going to be positive. So plus 16 times 10 should be equal to 0. Now, if you solve for FDF, what are you going to get? So 10 FDF, let's calculate everything. Minus 28 times 8 plus 23 times 16 plus 16 times 10. So that will give you 304. Meaning that FDF is 30.4 KIP. Okay. And then, but I think the question said we should find the force in member EF. So the question has been solved already. Because he said find the force in member EF. Oh. So we are even done. So why all this moment? In fact, we have already solved it. But anyways, you could have just ended at EF because the question said member EF. That's all. But I'm using this opportunity to teach you. That's why I did that. But we could have just end here at where he said about member EF because that is what we have done. I hope it is okay with everybody. So if you want FEJ, it would have been 16 minus FDF, which is what? 16 minus 30.4, and that will give us what? Minus 14.4 KIPS, and that will be what? FEG. But then the question did not say FEG. All right. So I think that is it. If you want to find the force in member JI, so member JI is this one. Member JI is this one. Okay. So again, you will pass a line or a section which will go through JI. Okay. But you have to be very careful. You have to be very careful because when you take the moment, okay, when you take the moment, what happens is that when you take the section, you have to pass it. You have to pass it so that it will go through JI. Okay. So to make it pass through JI, you cannot go like this. Okay. You cannot go like that. But you can either go by this or you can go by this, because whatever way you do, it will cut through 3 members. So now the choice is yours. So we can decide to go through vertically or we can decide to go through horizontally. Now if we go through vertically, what will happen? So if we decide to go through like this, what will happen? It means that we will cut all of this whole portion away, and then we will be left with this small portion here. Okay, so let's take that small portion. Okay, so there you are. This is what you are going to get. All right. So if you cut it into or if you cut it like this, then interestingly you see that this is FGI. Okay. Since the question did not say we should find any other force in a member but FGI, then we can just make the question simple for us by just looking at the moment about a point, which will let us find FGI quickly. Okay. So the best way to solve this is to, or you can also still do, you can still do summation of forces along the x equals 0, summation of forces along the y equals 0, and then use some moment. Okay, no problem. Let's do that one. I want you to understand it. So minus fgi plus 16, and then minus fhg will be what? 0. In other words, we can say that fgi plus fhg is equal to 16, equation 1. And then let's sum forces along the y. So to sum forces along the y, 33 is going up, and then this force here, fhi. So let's find the angle here. So this theta here will be tan inverse of opposite, which is 10, divided by this length. So the length is 8. So tan inverse of 10 divided by 8, what's that? 51.34. Okay, so basically if I resolve it along the then it means it will have a component along the x. Yes, it will have a component along the x. So minus fhi cosine 51.34. Okay, 0. And then with the y, we have 33, and then minus fhi sine 51.34 equals 0. So after getting this, okay, so we can say that fhi is equal to 33 divided by sine 51.34. So 33 divided by sine 51.34, which is what? 42.26 kips. So that is fhi. Okay, all right. So but then we still have to solve this. Okay, so if we put the value inside, then now we can say that fgi plus fhg should be equal to what? 42.26 cosine 51.36. Is that right? 51.34, sorry. So that is going to what? 42.26 cosine 51.34. And that is going to give you 26.4. So we have two variables with one unknown. So therefore, we need to sum moment. Now, if we sum moment, okay, so to sum moment, you can sum moment, or you have to sum moment about j, so that if you sum moment about j, it will eliminate fhg. Okay, so let's sum moment about j. Okay, so one thing that you have to also realize is that the y component of fhi will pass through j, the line of action will pass through J, so it will not give us any moment. But the y component will, sorry, the s component will give us some moment. All right. So this is FHI cos theta, FHI sin theta. Okay. So quickly, let's some moment about let's some moment about J. So summing moment about J clockwise is positive. What do we have? So starting from the 16 kips, it will be 16 multiplied by 10 about this J here. Okay, and then it's going to cause clockwise. (16 multiplied by 10) and then FJI. Okay, so FJI, taking moment here, FJI multiplied by 10, but that one will give us a counterclockwise moment. FJI will cause a moment about J in the anti-clockwise direction. So minus FJI multiplied by 10. In fact, this is what we were supposed to do. We should have just taken the moment because the question said you need FJI. So that is one trick about method of section. And then this FHI cos theta will cause a moment, which is also going to be counterclockwise. But the FHI is what? FHI, so FHI cos theta is actually this 26.4, right? Because FHI is 42.26 and then cos 51.34. So it is this 26.4 here. So minus 26.4, that is the FHI cos theta multiplied by 10 to be 0. So let's solve for FJI. So FJI will be 16 times 10 minus 26.4 times 10. So this one will be minus 104. And then if you divide both sides, FJI will be what? 104 divided by 10. And that gives us what? Minus 10.4 kips. So meaning that FJI is minus 10.4 kips. So it is a compressive force. So think about this. All of what we did here was a complete waste of time. Because if the question says find FJI, then everything which you did here is a mess. However, you don't know how the exams is going to be set. That's why I have taken my time to do all this mess, so that it will help you to actually understand how to do the analysis. Okay? And trust me, a trust question will come in the exams. By hook or crook, you are going to get a question on trust. But likelihood is that it's going to be method of joint, because that is where you do a lot of things. Or he can bring method of section, and you'll be asking you to be taking section all about. So you may end up taking more than one or two, or let's say three. But you can also say find the forces in all the members. There is something which we call zero force members. I cannot cover it tonight, but even if you don't know zero force members, if you calculate it, you will still get zero. However, if you don't know zero force members, it may take up your time. So any question up to this point, please? Any question up to this point? Now, because of time, unfortunately, I cannot do the pulley, but then I will urge you to go over equilibrium of rigid bodies, go over movement, go over forces in 3D, three-dimension forces, three-dimension movement, and then centroid, and you'll be happy. So at this point in time, if you want to get back to me, that is my contact there. I am giving some free space. Please, I cannot solve every question for you, but I'll give you the idea or the understanding. If there is a question which I have the solution already, I will forward the solution to you. And I have some questions which was sent to me which I was trying to solve. I'll try and send it by maybe an hour time, so that you can look at that question. But for now, if you have a question, please, you can ask. Other than that, I would like to end it here, so that you get time to also rest. Thank you everyone for joining. So if you have a question, you can say it or you can type it, I will see. Other than that, that's the end of the tutorial for today. Okay, so we are done with the tutorial. Thank you very much.